Okay, and you wanted to do 5 and 6?
Yes.
Okay, so let's check out number 5. Okay, so they gave us 1 0. I know that I'm going to be looking for how many zeros should there be altogether?
5. Wait. What did it be 5?
There, so find all your zeros. They gave you one of them. They gave you 5. So you need to find all the rest. So I'm
Oh,
wondering how many will there be when I'm all done?
4.
Yes, because that's my degree. So because the degree is 4, that means there's going to be 4 total answers when I'm all done. So I already have one of them that they gave me. They gave me 5. So I just need to find the rest. So I can use the one that they gave me as like a starting point. So first I take a look at what's here. And if this were 4 terms, I might try and factor by grouping. I'm going to look and see, can I factor anything out of this? No, so there's really nowhere I can go. So the only thing I can do is take that 5 that they gave me and do synthetic substitution and see what comes out. So let's do that. 4, negative 29, 51, negative 31, 5. And I'm going to plug in 5. So it's a negative 9, negative 45. That's going to be a positive 6, 30, negative 1, negative 5, 0. So that's a good sign that we ended with a 0 because we were supposed to. They told me that this works. So if I didn't get a 0 right there, then I messed up somewhere. But luckily we did, so we're good. Okay, so now what's left here are the coefficients of my new factor. So this, hold on. This is my constant. This would be x to the first, x squared, and x to the third. Okay, so now I'm here. So I'm going to rewrite this a little bit cleaner. 4x cubed minus 9x squared plus 6x minus 1. Okay, so now I'm at this point and I want to keep solving, right? I need to find the rest of my zeros because I haven't found any new ones yet. So I would try and factor by grouping. So cut it in half and then factor both sides, but pretty quickly you can tell that this one's not going to work. There's nothing, I mean, even if I tried, if I took out the x squared, I'd have 4x minus 9, but there's no way that this set of parentheses is going to be a 4x minus 9 over here. So that's not going to work. Okay, too bad, so sad. So our next option is to just keep going with synthetic. And well, we could try 5 again just to see if it's a double root. But to get all the other numbers that I'm going to plug in to test, that's where I take the factors of my constant and I'm going to divide it by the factors of the leading coefficient. And I have this list of everything that might work. Okay, otherwise you're going to plug in every number under the sun and that would take forever. It already takes long enough. We don't need more numbers in it. So if I just, let's see, where can I kind of stick this? I'll put it over here. So the factors of 5, luckily it's just 1 and 5. The factors of 4 are 1, 2, and 4. So that means all the possible rational roots are, so I'm going to abbreviate that, possible rational roots. I'm going to take 1 and divide it by each of these. And it's positive, negative. So positive, negative 1 divided by 1, positive, negative 1 divided by 2, and positive, negative 1 divided by 4. Then I do the same thing with 5. So positive, negative 5 divided by 1, positive, negative 5 divided by 2, and positive, negative 5 divided by 4. So in this list are all the numbers, all the possible rational roots. So if this thing has any more rational roots, they're in this list. Okay, so I'm obviously going to try and avoid plugging in the fractions just because they're annoying. So let's see if we can find another one that works. That's not a fraction. So I'll just start with 1. Well, what do you know? Hooray! So I found another one of my zeros. 1 works, so I can put 1 up in my list up at the top because I know that one works. I got a remainder of 0. And now I have, so there's my remainder. That's gone. I shouldn't have put an X because that'll be confusing. Okay. I don't need that. This is my constant. This is X to the first, and this is X squared. But now I'm down to a quadratic, 4x squared minus 5x plus 1. And I have all different ways to factor this thing. So I don't need, you could keep going with synthetic substitution if you wanted to, and just keep guessing them. But now that it's a quadratic, I can factor that. So let's see, factors of, I don't know how you do factoring when a is at 1, but I'm going to multiply a times c. Get x squared minus 5x plus 4. That's going to be x minus 1, x minus 4. I got to sneak in and divide both by 4. So I get negative 1/4. I mean, no, I don't. Just kidding. 4x minus 1 and x minus 1. Does that make sense how that you factor this? That? Okay. So now I have these and I set them both equal to 0. So it looks like I'm going to get a positive 1/4. And it looks like I get positive 1 again. So that means I'm actually, I'm going to write this a little bit. I'm going to write this differently then. So I get 1 with a multiplicity of 2. And then I'm just going to throw on that positive 1/4. Okay, does that all make sense?
Yes.
Oh, good. Okay, now we're going to take those zeros that we just found and we are going to slide over to the graph and now put them on there. So it was 5, 1 with a multiplicity of 2 and a 4th. Okay, so I'm going to clear all this and move on over. Okay, we said 5. Oh, wait. Shoot. Oh, no, we're right. Okay, I was thinking we were supposed to have 5 solutions, but no, it was 4, and we had all 4. Okay, good. 5, 1 with a multiplicity of 2. And what was the other one? 1/4?
Yeah.
Okay, so this is, there we go. That's the best I can do. And this thing was had a positive leading coefficient, and it was to the 4th. So that means my end behavior is going to be both up. Do you agree with that?
Yes.
Okay, so I'll just make this one go up, and this one's going to go up. All right, so now at 1/4, that only happened one time. So I know it's going to pass through the x-axis, but then it's going to come back. And when it hits 1, it's going to bounce right there because we got that multiplicity of 2. So I know it actually doesn't pass through, it just bounces. And then it's going to go off this way. Now, as far as these two right here, this little loopy-doop and this loopy-doop, you are welcome to plug in a number and see how low or how, how far down they actually go. Because it might even be less than that. They may just kind of bloop here and be kind of a little bit more, or they may go way down. I don't know. You wouldn't know unless you plug in another value. So if you want to, you can get a more accurate graph, but I'm really just concerned with your x-intercepts, your end behavior, and if you made it bounce or not.
Okay.
Does all that make sense?
Yes.
All right, perfect. Any other ones on this sheet that you want?
7 and 8.
Sure. Okay. Oh yeah, this one. Woo-hoo-hoo. Okay, so I'm gonna have 5 zeros at the end of the day. And they kind of gave me 2, right? Because if this is a 0, then its conjugate has to be a 0 also, because the imaginaries and the irrationals always come in pairs. So that means not only is negative 2 plus 3i a root, negative 2 minus 3i is also a root. So you've got 2 of them so far out of the 5. The problem is the 2 that they gave me are not really convenient. So you can use them. And this was, I posted another link to how to use these to kind of go right from here and do long division. Or you can do synthetic and just plug them in until you get one. So which option would you rather do? Do you want to use these zeros and do long division, or do you want to do synthetic?
Can you do synthetic?
All right, I like synthetic better too, to be honest with you. Especially because these numbers aren't that bad. Because 13 only has 2 factors, right? So 13, the only factors of 13 are 1 and 13. And 3 only has factors 1 and 3. That means the possible numbers that are going to work are positive negative 1, positive negative 1/3, positive negative 13, and positive negative 13/3. So not a huge list, so that's good. Again, I'm going to try the ones that are not fractions and hope that they work so I don't have to go down the fraction road. All right, so let's see. 3, 17, 60, 68, 9, and negative 13. And I'm not missing any degrees, right? 5, 4, 3, 2, 1, none. Okay, so let's just start with a positive 1. Yeah, this one's not going to work, right? It's just getting too big. There's no way that this is going to end up being a positive 13. So, okay, we'll undo that. Let's try negative 1. Oh, what's that? 22?
Yeah.
Negative 22. Negative 13, 13, 0. Okay, awesome. So now we know that negative 1 works. So I need to, if I were to stop right here, that's my constant x to the first, x squared, x to the third, x to the fourth. This is too big. I can't just stop and factor it. So I need to keep going with synthetic. But I know, let's add negative 1 to my list. Okay, and I might try negative 1 again just to see if it's a double root. So sometimes I like to just keep going right on this. Less writing. So and the other thing is that since positive 1 didn't work before, it'll never work. So I don't have to test that again. 35, negative 35, negative 13. Ooh, look at us. We found another one. Okay, so that means negative 1 was a double root. All right, so now I could try and factor this by grouping, but I still don't think it would work. So yeah, I'm not gonna, yeah, it wouldn't work. You could try negative 1 again to see if it's a triple root. Could be. I'll try it. What the hey? $27. Nope. Okay. So we are done with the negative 1s. So now let's try the 13s, I guess. Yeah, that's just way too big, so that's not going to work. Okay, we can try negative 13. What's that? Negative 28. That's way too big. Okay, that's not going to work. So now I have to look at my fractions. All right, we'll try 1/3. See how that goes. So 1 bring down the 3. 1/3 of 3 is just 1. That's 12. That's 4. 39. Hey, look at this. So 1/3 worked, and it wasn't too bad. So let's add 1/3 back up to my list. And remember, I'm only looking for 5, and I have 1, 2, 3. Oh, do I have them all? I have them all. 1, 2, 3, 4, 5. Yeah. So if I took this, the 3x squared plus 12x plus 39, and I solved this one, guess what my solutions are going to be? It's these two that I kind of didn't bother with because they were annoying. So
Yeah.
if I had started with them, I would have gotten this factor to begin with. So then I could have taken that and done long division into the original to get the rest. I don't know. I think that's more annoying, but
Yeah.
also though, it depends on what my list looks like. If these end numbers have like, tons of factors, I'm like, oh, it's going to take me all day to do synthetic, so I wouldn't bother. But this list was pretty small, so it wasn't that bad. But yeah, you can do it either way. So there's that craziness. So now, does all that make sense so far?
Yeah.
Okay. So now we got to try and graph this thing. All right. Let me erase all this so I can access my graph. All right, so let's put some dots on here. We need to switch colors. So we have -1, it's going to bounce. Oops, I'm still in eraser. There we go. -1, we got that with a multiplicity of 2. We also got 1/3. Okay, and then we have the 2 imaginary ones. So they are not going to show up on my graph, right? Because they're imaginary and we are plotting in the real number system. So let's see. My leading coefficient of the original is positive, and my degree is to the 5th. So that means my end behavior is going to look like this. This one's just going to go up this way. This one's just going to go up off this way. All right. So one thing we should do is just find our y-intercept, because that's easy enough. So if I plug in 0 for x, looks like I'm going to end up with a -13. So I do know that it crosses at 0, -13. So what it looks like is happening is at -1, since it was a double root, it's going to bounce right there. And then it's going to come all the way down here and hit that -13. And then come up to cross at 1/3 and then go off. Oops, there we go. So something along those lines. Does that make sense?
Yeah.
Okay, good. All right. What else you got? Anything?
Actually, I think I'm all set.
Yeah, okay. These ones are weird, the imaginary ones, so I'm glad that worked out. All right, my dear.
Yeah.
Well, I hope you have a wonderful week. Thank you, as always, for coming on with me.
You're welcome. I hope you have a good week too.
Thank you. Talk to you later. Bye.
Okay. Bye.